My name is Anushree, third year BE in Information Science and Engineering student at Sri Venkateshwara College of Engineering, Bengaluru. Today's topic of my presentation is NFA, that is Non-Deterministic Finite Automata, from the subject Automata Theory and Compiler Design, and the subject code is 21CS51. So, first of all, what is an NFA? A non-deterministic finite automata is easy to construct an NFA than a DFA for a regular language. The finite automata are called NFA when there exist many paths for a specific input from the current state to the next state. That is, every NFA is not a DFA, but each NFA can be translated into a DFA. NFA is defined in the same way as DFA, but with the following two exceptions: it contains multiple next states and it contains an epsilon transition. And if it contains an epsilon transition, it is called as epsilon NFA. So let us see that what is the formal definition of NFA. In NFA, capital Q stands for finite set of states in the transition, and the sigma represents the finite set of input symbols, that is the alphabet. That is, Q0 is the initial state and F is final state, and this transition function is defined by this symbol. So what is the graphical representation of an NFA? The state is represented by the vertices. The arc labeled with an input character show the transitions. The initial state is marked with an arrow and the final state is denoted by the double circle surrounded by it. Example 1. The transition diagram. Let us learn how to understand the transition diagram. So first we have the three states, that is Q0, Q1 and Q2. Here we know that Q0 is the start state by the arrow represented beside it. So Q0 on transition 0 or 1 goes to Q1 and it has the double transition, that is multiple transitions from the current state to the next state. Q0 next state for the input 0 will be Q0 and Q1. Q0 for the next state for input 1 will be transition Q1. So Q1 on the next state for input 0 will be Q2 and Q1 on 1 will go to Q0. Q2 is the final state as it represented by the star beside it, and the Q0 next state for input 0 is Q2 and Q2 on the next state for input 1 will be Q1 and Q2. The alphabets were 0 and 1 and Q0 will be the start state and final state will be Q2. So example 2, NFA with a alphabet 0 or 1 accepts all the strings with 0, 1. So here we need to design an NFA which accepts all the strings with 0 and 1. So Q0 on 0 will go to Q1 and Q1 on 1 will go to Q2, that is final state, and Q2 with all the zeros and 1 will accept it itself and Q2 will become the final state. Present state will be Q0, that is the start state. Q0 on the transition 0 input will go to Q1 and Q0 on the input 1 will transition go to epsilon, that is Q0 on 1 will not go to anywhere because it will not accept anything with 1. So we need to accept all the strings with 0 and 1. So Q1 on transition 0 will be epsilon and Q1 will transition 1 will go to Q2. Q2 is the final state here and Q2 on the input 0 will then go to Q2, that is final state, and Q2 on transition 1 will also go to Q2. That is, it all accepts all the strings with 0 and 1. Example 3. NFA with an alphabet 0 and 1 and accept all the strings of length at least 2. So it should contain the length at least 2, that is 2 or more, and it should contain 0 or 1 any number of times. So Q0 on 0 or 1 will go to Q1, Q1 on 0 or 1 will go to Q2, and Q2 doesn't accept anything, so it will be the final state here. So we can see that Q0 on input 0 will go to Q1, and Q0 on input 1 will also go to Q2, because we need to accept all the strings with at least length 2. It may contain 0, 1 or 1, 1, 1 like that. So Q1 on input 0 will go to Q2, Q1 on input 1 will again go to Q2, that is final state. So let us understand how to design a NFA for the transition table given. Present state will be Q0, Q1, Q2, Q3, and Q0 on 0 will go to Q0, Q1, Q0 on 1 will go to Q0, Q2, Q1 on 0 will go to Q3, Q1 on 1 will go to epsilon, that is nothing. So Q2 on 0 will go to Q2 and Q3, Q2 on 1 will go to Q3, Q3 on 0 will go to Q3, and Q3 on 1 also will go to Q3. So here's the diagram you can see. So epsilon transition of Q0 on 0 will go to Q0 and Q1. As you can see, Q0 on 0 will go to Q0 itself, and Q0 on 0 will also go to Q1. So it is Q0 Q1. So transition of Q0 on 1, that is Q0 on 1 will go to itself, that is Q0, and also Q0 on 1 will also go to Q2, that is Q2. Here then Q1 on 0, that is Q1 on 0 will go to Q3. So Q2 on 0 will go to Q3 and also itself, that is Q2 Q3, Q2 and Q3. Q2 on 1 will also go to Q3, Q2 on 1 will go to Q3. Then Q3 on 0 will also go to itself, that is Q3, and Q3 on 1 will also go to itself. Q3 on 1 is also Q3. So you can design the transition diagram, I understand. Difference between NFA and DFA. DFA stands for the deterministic finite automata, and NFA stands for a non-deterministic finite automata. For each symbolic representation in a DFA of the alphabet, there is only one state transition in DFA. DFA cannot use empty string transition. DFA can be understood as a one machine. DFA is more difficult to construct. DFA rejects the string in case it terminates in a state that is different from accepting the state. Time needed for executing an input string is less. All DFA are NFA. DFA requires more space. Dead configuration is not allowed in DFA. But whereas NFA stands for the non-deterministic finite automata, no need to specify how does the NFA react according to the same symbol, that some symbol. NFA can use empty transition state rather than DFA. NFA can be understood as a multiple little machines computing at the same time. NFA is easier to construct. NFA rejects the string in the event of all the branches dying or refusing the string. Time needed for executing an input string is more. Not all NFA are DFA. NFA requires less space than DFA. Dead configuration is allowed in non-deterministic finite automata. So that's all for this video. Thank you.